Students, simple analog periodic signals की बात चल रही है, and we are discussing a key attribute of the simple periodic analog signal or a sine wave, which is called as frequency. Students, we'll go to the slide and we'll do a couple of examples which allow us to convert the different units that we studied in the previous topic, and that was around the units of frequency and the units of period and how these units are interchanged, and if you're given one, how do you calculate the second one? So we'll see that on a slide. So students, in the first example, we'll see what the period of a power sine wave is, which normally represents the power that we use at home. Students, we know that the frequency of the power that we use at home is 60 Hertz. Now, to calculate the period, we employ the formula that we already know, which is period is equal to 1 over f. This is equal to 1 divided by 60 Hertz, where 60 Hertz is the frequency of the power. This comes out to be 0.0166 seconds. And if you convert it into its appropriate units, this comes out to be approximately 16.6 milliseconds. So students, this essentially means that the period of the power for our lights at home, for example, is 16.6 milliseconds. Now, if you try to think about it, the period, which is 16.6 milliseconds, is so small that our eyes do not find out any difference or are not able to distinguish the rapid change in the amplitude, although we can clearly see that the light is completing one cycle in 16.6 milliseconds, and then it repeats the same pattern again. Our eyes are not sensitive enough to actually understand the difference. Another simple example, students, we have got a period of a signal which is given to us as 100 milliseconds, and we need to find out the frequency in kilohertz. So students, the first step is to convert 100 milliseconds using the units that we have already discussed to seconds. So we have got 100 milliseconds. Now we know that this is equivalent to 100 multiplied by 10 raised to the power 3 seconds, and this is essentially equal to 10 raised to the power minus 1 seconds. Now students, after the conversion of this period, we can find the frequency as 1 divided by t, which is 1 divided by 10 raised to the power minus 1, and this is essentially equal to 10 Hertz. The requirement, however, is to calculate the frequency in kilohertz. So if you multiply this by 10 raised to the power minus 3 kilohertz, you will come up with a value of 10 raised to the power minus 2 kilohertz. So students, this was a little bit about frequency. Before we leave this attribute of a sine wave, we are going to talk about the last concept. Although we have studied that the frequency of a sine wave is the number of cycles that the sine wave completes in 1 second. Another way of defining frequency is to define it as the rate of change of the sine wave over time. Students, if there is no change in the sine wave, if there is no change in the audio, if there is no change in the voltage, then the frequency of that sine wave is 0. On the other hand, students, as you can imagine, because it's the rate of change, if the change is instantaneous, it's so quick that we can't even find an interval between the two changes, then the frequency of such a sine wave is infinite. So the two extremes that refer to this attribute frequency of a sine wave are: if there is no change in the signal, the frequency is 0. If the change is instantaneous, the frequency is infinite.